Hello everyone. So now we'll start with the second topic of design for test. So that is scan design and boundary scan. So here these are the two techniques which are used to detect the faults in the sequential circuits rather than combinational circuits. So it is also used in combinational circuits but more preferred for the sequential circuit. These two techniques allows the designer to control and observe the outputs of the sequential circuits. So now we will discuss first the scan design importance. Here this is a scan design technique which address the problems by modifying the registers to allow them to be chained into a long shift register. So this is a long shift register which uses 3 D flip-flops. We call them as scan chain. Okay, so now we will discuss how the scan chain technique allows us to control and observe the outputs of the each flip-flop. So here the flip-flop is nothing but D flip-flop and we can detect the faults. So now look at the inputs and outputs of this long chain shift register. So here it has the inputs like data in, scan in, test mode and the clock. The outputs are data out and scan out. There are 3 D flip-flops are used which are interconnected here in a cascade, and muxes are used just to provide a feedback path so that they act as a sequential circuit, or it is a sequential data path. So now, so what we will do, so data in is the input which is given to the flip-flops, scan in which holds the expected result here, expected result or the expected data which is need to be produced at the output of each flip-flop, test mode which is used to control the comparison of the output of the flip-flop and the scan in data. So clock which is used to process the information or the data in the registers or in the flip-flops. So now we'll assume that when the clock signal is applied for this scan chain or for each flip-flops, here the output is available at the Q bit, or you can say that at the Q output we can observe the outputs. So now the scan in data compares the outputs of each flip-flop. So if the comparison is similar or the expected result matches with the outputs of each flip-flop, then we can say that the output of each flip-flops is correct. So if there is any variation or difference in the outputs, then it will allows us to check or to detect there are faulty outputs in the flip-flops. So this is the way where the scan chain is used to detect the outputs, and it also allows us to control the outputs of the each flip-flop by using test mode signal, and it allows us to observe the output when clock signal is applied for the flip-flop. So this is about the scan chain design is a technique which is used to detect, to control and to observe the outputs. So now there are some advantages here. So the first advantage, here it increases the controllability and observability of the scan design. The second advantage is that it is used to design and synthesize the circuit normally, so generating a gate level circuit with flip-flops implementing the registers. So here that one of the advantage shown here, this is a normal flip-flop provided with one mux and one OR gate. So these two are combinational circuits, this is a sequential circuit. Here combinational circuits are used to control and observe and detect the output of the sequential circuit. So thereby this is an advantage, but it also yields the disadvantages of the scan design. So the disadvantage is that here, so the disadvantage of scan design is the overhead, because both in the circuit area and delay, because we have added here the additional combinational circuits. Those additional combinational circuits will increase the delay and the circuit area. So another one is, So here in the scan design, when compared to some other DFT techniques, the scan design is very long. Means nothing but because of more number of flip-flops connected in a long shift register, here it requires more time to compute the results. So this is about scan design technique. Similarly, you can go through the boundary scan. The notes is given, just go through it and verify the outputs. Thank you.